Okay, hello, welcome to your math lesson. This is lesson number 7. And I'm glad I had you read through this lesson ahead of time because it can be a little bit complicated. We go over inductive and deductive reasoning, and then logic, and then the contrapositive, and converse and inverse. So a lot of new things. We're going to try and be wise as we do this. Look at that. Do you think that was a wise move? Probably not the wisest thing they ever did, huh? All right, so let's just start at the beginning, and we're going to go through inductive reasoning. And inductive reasoning is the process of trying to find a rule. And so, for example, what they use as an example is if you're flipping a coin and you flip it 100 times, and 40 of those times it comes up heads and it's tails 60 times, you might take this data and you might induce, there's that word again, induce a rule. And the rule would be when you flip a coin, you always get more tails than heads or whatever. And then you might repeat the experiment and see if that rule is true or not. So it's about gathering the data, making observations, and then making a guess as to what a rule would be. Okay, then there's also deductive reasoning. And deductive reasoning is the process of using a rule once it has been made. So you've already got a rule and you try and use that rule to reach conclusions. Okay. Now, it could be true and it could be not true. And the way that you could end up with a conclusion that's false, like Dwight is saying here, is you could have a false rule and you take that false rule and you use it properly, but it's a false rule to start with. That would be, the reason I put a calculator here is that would be kind of like a broken calculator. So if you have a broken calculator, even if you use it right, you're going to get a wrong answer. Okay, and then you could also reach the wrong conclusion with deductive reasoning if you have a true rule. So let's say you have a calculator that works perfectly, but then you use it wrong. Maybe you punch in the wrong numbers or something like that. All right, let's go over the next section, which is about logic. And it's talked about how the ancient Greeks used a system of syllogisms in their investigation of deductive reasoning. So this is how they did deductive reasoning. A syllogism is a formal process. It's like a reasoning process where you get to a conclusion with two statements, and those two statements are called premises. Okay, and so we're going to look at premises. There are different types of premises. It can be a categorical proposition, and that puts things in categories. So that makes sense. Categorical proposition puts things in categories. And then there can also be universal affirmation. And that means that once you have a category, all members of that set or of that category have a certain property. Okay? All right. This premise is usually called, let's see, is this one the major or the minor? This premise is usually called the major premise, where you say all something have this property, all boys have this property, all athletes have this property, all animals or whatever. So that's usually the major premise when we start looking at premises here. And then that's the major premise. You'll recognize it because it has the whole set. If it says all turtles are green or whatever, that's the whole set, and that's the major premise. A minor premise involves a member of the set. So if you say all boys have hair, I was going to say brown hair, but then I was like, whatever, they don't all have. I'm going to say all boys have hair, and then you say Danny is a boy, so he must have hair. The minor premise is that Danny is a boy, because that's identifying just a member of the set instead of talking about all boys. So there's a major premise talking about the whole set. There's a minor premise talking about just a part of the set. All right, so let's start looking at these. The first one that they show as an example is an old syllogism, apparently one of the oldest syllogisms known, and it's like this: all men are mortal. That's the major premise. It's talking about the set of all men. The second premise or the second statement is Aristotle is a man. This is a minor premise because it just identifies Aristotle. And then it's kind of like an equation, so you kind of add those together to get to your conclusion. Therefore, and you'll notice in the future when I write the word therefore, I just do it with 3 dots like this. That's like an abbreviation for the word therefore. Therefore, Aristotle is mortal. So does that make sense? All men are mortal. The minor premise is Aristotle is a man, therefore Aristotle is mortal. Okay, and this is how the Greeks decided, well, this is logical, this makes sense. Then you can conclude that this conclusion is true. And you can do this with math. This is why we're talking about it in math. You can say something like, the sum of the exterior angles of a convex polygon is 360 degrees. And then you say, triangle ABC is a convex polygon. And then if you know both of those things, then logically what happens is, therefore, the sum of the exterior angles of triangle ABC is 360. So you know a rule, and then you apply it to a subset of that rule. Hopefully that makes sense. Okay, and then that's the argument. So when you have a whole set of statements like this, it is actually called an argument. Like if you were presenting this information in court, then the jury could decide that they would have to agree with you because you presented your argument. All right, here's another syllogism that we can look at. Oh, it doesn't mean that the conclusion is true. It just means that if this is true, then and this is true, then this is also true. But one of those premises might be false, or, just like the calculator thing, it could be not true or not right, or you could have not used the argument right. So you have to look for ways that could be not true. All right, so let's go over this one. The major premise is this one. All frogs are green. It's the major premise because we're talking about all frogs. This is the minor premise. Henry is a frog. Look how cute Henry is. He's adorable. Okay, therefore, Henry is green. And it turns out that this argument is valid. So we're going to be deciding if the argument is valid or not. Imagine that you are on a jury and you're watching a lawyer present this case. Did the lawyer make a good argument? And if he presented a major premise and then a minor premise, and the conclusion seems right from that, then you can say that it is valid. You went through that logically and in a valid way. Okay, let's look at another one. So that one is a valid argument. Oh, also note here that it might not be true, right? You can have yellow frogs, right? But in this case, the major premise was not true, but we're not talking about true or false here. We're just talking about, is it logical? Is it a valid argument? Okay, so it doesn't have to be true. You can say it's a valid argument and it's not even true. Okay, let's do the next one. Here's an example of an invalid argument. So I'm going to tell you from the beginning that it's not valid. Here it is. Major premise. If it rains, I will go to town. The minor premise is it did not rain. Therefore, I did not go to town. So if you're sitting on a jury and you hear a lawyer say this, you're saying, if it rains, I will go to town. So that gives you information on what a person does when it rains. But it did not rain. So this is not part of this subset. This is the subset of days. The set that it's describing is days that it rains. So this has nothing to do with days that it rains because it didn't rain. So therefore, we're going to say that this is an invalid argument because it didn't rain. So it doesn't tell you if it could be something like, if it rains, I will go to town, but if it doesn't rain, I might go to town, I might not. It doesn't tell you anything about what you do if it doesn't rain. So this is an invalid conclusion. Okay, so that's kind of how it works. Let's do another example. Let's do example 7. Is this valid or not? Okay, so here's the major premise. All normal dogs have 4 legs. Again, don't worry about whether it's true or not. We're just saying if it's a valid argument. So the set is all normal dogs have 4 legs. And then the minor premise is that dog has 4 legs. Therefore, that dog is a normal dog. So we don't know if that dog belongs to this set or not. So this argument is going to be invalid. because the set that they're talking about is all normal dogs, and we don't know if that dog is a normal dog. Like, you could have 4 legs but still not be a normal dog. It doesn't necessarily go backwards. Speaking of going backwards, we're going to go to that next, but for now, just know that that is not a valid argument, because the described set is the set of normal dogs. So for a valid argument, you would have had to say, that dog is a normal dog, and then you could say, therefore, that dog has 4 legs. That would be valid. That would be how I would change it to make it valid. Okay, next example, 7.2. All boys are good. That's the major premise. The set is all boys. The minor premise is that child is a good child. Therefore, that child is a boy. What do you think? Again, this is invalid. If you were the jury and you were hearing a lawyer say this, you'd be like, that is not logical what you just said, because you just said all boys are good. And when you're saying that child, you don't indicate that that child is a boy. And so you don't know if it's a good kid or not. You're just saying it's a good kid. But you could have a good kid that's still a girl. So this is not logical the way they do that. So the major premise here makes a statement about the set of all boys. The minor premise talked about the set of good children. So that's 2 different sets. For a valid argument, the minor premise has to identify a member of this set. Okay, that's why it's not valid. Let's do the next example. Example 7.3. Is this a valid argument? Why or why not? Okay, all chickens have 3 legs. I had to add an extra leg to the picture of that chicken because obviously that's not true, but we're just saying, is it logical? So if you believe that all chickens have 3 legs, and then the minor premise is Henny Penny is a chicken, therefore Henny Penny has 3 legs, that's actually a valid argument. It's logical. Of course, all chickens don't have 3 legs, but you can still say that the argument is a valid argument. It doesn't mean that the conclusion is true. It just means the argument is valid because the major premise identified a property of the set of all chickens, and the minor premise identified Henny Penny as a member of that set. Okay, let's move on to what the contrapositive is. Okay, the major premise, when you look at the major premises that we've looked at, it's basically an if-then statement. All chickens have 3 legs. If you're a chicken, then you have 3 legs. If you're a chicken, then you have 3 legs. It's kind of, if you word it differently, it's kind of an if-then statement. The other way to think of an if-then statement is as a hypothesis and a conclusion. So a hypothesis begins with the word if. If you're a chicken, you can conclude then that you have 3 legs, right? So when the words if and then are not written, you can kind of change it so that it has those words. For example, a premise might be rabbits are fast runners. Let's change it so you can identify what's the hypothesis, what's the conclusion. Rabbits are fast runners. So the hypothesis would be, if an animal is a rabbit, then the animal is a fast runner. This part is a hypothesis, this part is the conclusion. And also notice that there's an arrow from one to the other. So the premise is a one-way process. The premise does not say that all fast runners are rabbits. It does not say that all fast runners are rabbits. It just says, if an animal is a rabbit, then the animal is a fast runner. Okay, now, speaking of negation or changing it, this is a way, negation, think of the word negative, like you're so negative. Negative is when you use the word not or non, like this is a non-rabbit. That would be like negating it, right? A non-rabbit. So that changes the statement. If you wanted to say, if an animal is a rabbit, okay, so if an animal is a rabbit, if it is a rabbit. The way you would negate that is you could say a couple things. Is not a rabbit, you could say that, if an animal is not a rabbit, or you could say if an animal is a non-rabbit. So those are the two ways that you can change it. Okay. If you change the sense of the if statement, like not or non, you can also make a contrapositive. So this is a new vocabulary word. Contrapositive means a double negative. It's changing the if statement and it's changing the then statement. So I will show you how you do that, but that is considered a double negative. You make the then into a negative, and then you have the negative of if. So when you do a contrapositive, you are actually going to change the order too. It's kind of like you change the if, you change the then, and then you also change the arrow. Instead of going that way, you're going that way. You start with the then and turn it into an if. We have to see this in motion, right? Because that's really hard to understand. Let's start with this. If an animal is a rabbit, then the animal is a fast runner. Okay, so what would be the contrapositive of that? I'm going to write it above it. We start with the then. This is the then. Then the animal is a fast runner. So I'm going to write the then over here, and I'm going to make it negative. The way to make it negative is to say let's see, if the animal, let's change it. If the animal is not a fast runner, then I'm going to change this. Then the animal is not a rabbit. Okay, so I just did the contrapositive of the previous statement. Okay, and it turns out that if the premise is true, the contrapositive is also true. And if the premise is false, its contrapositive is also false. And you can put a Venn diagram to show you. Oh, I should have written it here. Then I could compare both of them and say they're both true, but that's what I meant to do, but oh well. All right, this is what I just said. If a premise is true, then its contrapositive is true. If a premise is false, the contrapositive is false. You can use a Venn diagram to show you that. So here's the diagram, okay? And then in this circle, we have everything that's fast. All of these means it's not fast. It means it's slow, I guess, but they're just saying not fast. Okay, and then within the fast animals, I put rabbits right there because they are just a subset of the fast. But you could be fast and not be a rabbit. That would be the cheetah right there. And you could be not fast and not be a rabbit. So let's make sure that those premises are false. Let's review them. If the animal is a rabbit, then the animal is a fast runner. So the rabbit is here and it's inside the circle indicating fast. So that's true. And then it says the contrapositive that we came up with was if the animal is not a fast runner, then the animal is not a rabbit. So if you're not a fast runner, you're going to be out here in these areas, and you're not a rabbit because there's going to be no rabbits out there. So that's also true. Oh, this is getting confusing, isn't it? Let's go over some examples and I think it'll make more sense. Let's see if this argument is valid. So our job here is to decide, is the argument valid? This is example 7.4. It says, all non-athletes are vegetarian. This is the major premise. This is the set. All non-athletes are vegetarian. Jim is a non-vegetarian. Therefore, Jim is an athlete. Okay, so this is a little tricky because we have to change this now that we know some stuff about the contrapositive. we have to go ahead and change this. And it makes it tricky to understand, but it's easier if you do an if-then format. So let's try that, turning this into an if-then format. So all non-athletes. So let's say if you're a non-athlete, okay, and then I'm going to put my arrow. If you're a non-athlete, then you are vegetarian. I don't know why I have that written twice. Then you are a vegetarian. Whoops. Let's try this. Okay. Okay, so we change it to if non-athlete, then you're a vegetarian. And then it says Jim is a non-vegetarian. This is the minor premise. So the major premise makes a statement about the members of the set of non-athletes. And the minor premise says that Jim is a member of the set of non-vegetarians. So you remember that a premise, you can replace a premise with its contrapositive. So we're going to have to replace the major premise with its contrapositive to decide if this is valid or not valid. So we're going to reverse this. Okay, so we're going to add non. We're going to add the word non. Okay, so if you're a non-vegetarian, we're going to do the contrapositive. Let's just, all you do is, when you do the contrapositive, you're going to replace the nouns and then replace each noun with its negative. So okay. If you're a non-vegetarian, then you are a non-athlete, and a non-athlete is just an athlete. So it's the opposite of that. So we replaced the major premise with its contrapositive. And now, does this one make more sense? Jim is a non-vegetarian, so it is a member of that set. And then it says he's an athlete. So this argument is actually valid. Now that we know this information about contrapositives, we can say it's valid. Okay, that was a little confusing, so I'm going to be like Jack Black here and be like, whatever. And let's move on. We have converse and inverse. This is, this is along the same lines. We're going to look at a couple of our premises in abbreviated form. So for example, if you're a normal dog, then you have 4 legs. If you're a rabbit, then you're fast. If P, then Q. So this is our premise, and this is like the conclusion, or this is the result. Okay, so we read this by saying if P, then Q. If I do this, if I put that in front of it, that means not P. So this one means if not P, then not Q. This is the contrapositive because we changed the nouns. So we changed the place of the nouns, and we basically reversed the arrow just because we moved it, it's now going in the other direction. If not P, then not Q. That's the contrapositive. So we're going the other way. So this is the premise. These are the contrapositives. If P, then Q. If not Q, then not P. This is all valid. Okay. All right, now let's talk about the converse, though. Because there are 2 other forms of interest to the person who's interested in logic. So the first other way to do this is called the converse. So remember, the original one was if P, then Q. The converse is if Q, then P. And that turns out that you can't do it that way. If you do it that way, it may not necessarily be true. The inverse of that is if not P, then not Q. Oh my gosh. Okay. A lot of times when we have trouble with logic, it's because you assume that the converse is true if the premise is true. And so you can't assume that the converse is true. That would be a false assumption. Okay. You can have some that go both ways. And if it is something that is true in both directions, then it's called an if and only if statements. Here's an example of an if and only if statements. And this means all definitions are true in both directions. If it's a 90-degree angle, then it's a right angle. That means P is the premise. If an angle is a 90-degree angle, then it's a right angle. But you can also say if it's a right angle, then it's a 90-degree angle. So that's the converse that I just did, and that's also true. And so that one goes in both directions. It just happens to go in both directions. And that's an if and only if statement. Okay, if you're feeling like this right now, don't worry about it. That's the end of your lesson. Good luck with your homework. Bye.